Hello, am I audible? Hello, ma'am. Am I audible? Hello. Please, anyone, let me know. Am I audible and am I visible? Atul. Hello. Hello, ma'am. Okay, it's already 5 p.m. Okay, 1 second, please. Sorry for inconvenience. Good afternoon, all students. So, welcome to Sankalpa Sanmarga classes. Here, I am Achala Bhatt, chemistry faculty. I am teaching you structure of atom. So I the screen is visible to you. Structure of atom. So what we are going to study under structure of here, actually, uh, here actually we are studying the synopsis on structure of atom. Initially, at the beginning, ancient India considered as atom is uncuttable. Atomio, the word atom comes from atomio, which means uncuttable. So here, uncuttable means which cannot be further divided. So this atom means which cannot be further divided. The substance which cannot be further divided, but the later inventions showed that atom is not uncuttable or indivisible particle. It can be divided to subatomic particles. There are many subatomic particles discovered. Let us study it one by one and let us study structure of atom. How atom is made up of. Here, discovery of fundamental particles. How this discovery of fundamental particles were made. Initially, the Dalton who said that atom is uncuttable, but after some experiments were done based on that, subatomic particles like neutron, proton, and electron, neutron, proton, and electrons were discovered, and also positron, neutrino. These are the particles. So, what is neutron? Neutron andre ಏನ್ ಹಾಗಿದ್ರೆ? Neutron is subatomic particle which is having charge zero. Neutron is having charge zero, whereas proton will be having charge plus. Proton will be having plus charge, whereas electron will be having negative charge on it. So, who discovered electron? These are some important questions. Who discovered electron? J.J. Thomson, scientist who discovered electron in 1897. And these are negatively charged particles. And protons were discovered by Goldstein. You have to remember these scientist names. Goldstein discovered proton, which is positively charged, and Chadwick, the scientist called Chadwick, he discovered neutron. So neutron was discovered by Chadwick. How? He bombarded beryllium sheet with helium particle. Here helium, whenever I say helium nucleus, which means alpha particle, because alpha particle is nothing but which is having two positive charges. Therefore, helium also contains two protons in nucleus. Therefore, this when alpha particle hit this beryllium, they observed that carbon forming and one uncharged particle was coming out from this sheet. He named it as neutron. Since it was neutral, it was not having any charge, this is called as neutron. Next one. So, how electrons were discovered? You have already studied, I think, in your theory classes. Due to cathode ray tube experiment. Cathode ray tube experiments ಮಾಡುವಾಗ ಏನಿತ್ತು? The cathode ray tube ಏನಿದೆ, it is made up of glass about 60 centimeter long, containing two thin pieces of metals known as electrodes. Here, these two are electrodes. They are called as cathode and anode. Cathode will be having charge negative, anode will be having charge positive. So here, these are the two electrodes which are established in glass tube, and negative electrode is called as cathode, positive electrode is called as anode. The credit of discovery of electrons goes to J.J. Thomson, who did experiment involving cathode ray tubes. So again, initially I have mentioned who discovered electrons. Electrons were discovered by J.J. Thomson. So when gas is at very low pressure, that is about 10 raised to minus 4 atm, look at here, it is 10 raised to minus 4, 10 raised to minus 4 atm, atmospheric pressure. Atm is nothing but atmospheric pressure. Discharge tube is subjected to high voltage, which is about 10,000 volt. It is 10,000 volt. And he observed that some invisible rays originating from the cathode. And so, how he observed invisible rays? It is a question. So that he made to fall that invisible rays on zinc sulfide, which is a fluorescent material. Zinc sulfide is fluorescent material. What is fluorescent material then? Fluorescent material is nothing but, see, when you're going through NH alle hoguvaga, there you observe red on, which may be yellow color or red color. When light flashes on it, they get reflected or they start to shine. That is called as fluorescent material. When light particle falls on them, they start to shine. ಅಥವಾ ಕೆಲವೊಂದು ಬೋರ್ಡ್ ಇರ್ತದೆ ಗ್ರೀನಿಶ್ ಕಲರ್, ವೆನ್ ಲೈಟ್ ಫಾಲ್ಸ್ ಆನ್ ಇಟ್ ದೇ ಗ್ಲೋ. ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? ಫ್ಲೂರಸೆಂಟ್ ಆರ್ ಫಾಸ್ಫೋರಸೆಂಟ್ ಮಟೀರಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸಿ ಹಿಯರ್, when the invisible rays, when the invisible rays from cathode, when the invisible rays from cathode moving towards anode, they will fall on the zinc sulfide. Here there will be zinc sulfide coating. When these invisible rays fall on this zinc sulfide solution, they shine, ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ವೆನ್, ಇಲ್ಲಿದೆ ಲಾಸ್ಟ್ ಸೆಂಟೆನ್ಸ್ ಇದೆ ನೋಡ್ರಿ, behind the perforated anode on the glass wall coated with phosphorescent material, zinc sulfide is observed. So here this is high voltage, this high voltage is observed, high voltage is observed. And here vacuum pump, why this vacuum pump is used? Because to evacuate the tube, we have mentioned here why evacuation is needed, because to emit this invisible rays or cathode rays from cathode to anode, we require very low pressure of gas. Only in low pressure of gas electricity is passed. This is about cathode ray experiment. Then what are the properties of cathode rays? So we know that cathode rays, what are the cathode rays? Cathode rays are the rays produced at cathode and they move towards anode. That we can say in properties of cathode rays. So here, what is cathode? Properties of cathode rays. Properties of cathode rays. Always the cathode rays move in a straight line. Cathode rays always move in straight path or straight line. And cathode rays produce mechanical effect. You know, when ಏರ್ ಪಾಸಸ್ ಅಥವಾ ಏರ್ ಟ್ರಾವೆಲ್ ಆಗ್ತಿರುವಾಗ ಏನಾಗ್ತದೆ, ಮರದ ಎಲೆ ಎಲ್ಲ ಅಲುಗಾಡ್ತದೆ. ಅದೇ ತರ ವೆನ್ ಕ್ಯಾಥೋಡ್ ರೇಸ್ ಆರ್ ಪಾಸ್ಡ್ ಥ್ರೂ ಆರ್ passed with some wheel, mechanical wheel, they observed that mechanical wheel is going to rotate. So they mentioned that cathode rays produce mechanical effect. Cathode rays ಏನಿದೆ mechanical effect ಅನ್ನ produce ಮಾಡ್ತದೆ as they can rotate wheel that placed in their path. In presence of electric or magnetic field, the cathode rays get deflected from their straight line path. So you know that cathode rays are having negative charge. Already I have mentioned cathode rays are nothing but they are electrons. So when they are passing in a straight line, they will be deflected from their straight path because they are negatively charged. They will move towards, they will deflect towards positive charge. We know that negative charge will be attracted by positive charge. Therefore, while traveling, they are attracted towards positive charge when there will be electric or magnetic field is present. Cathode rays consist negatively charged particles as electrons. Okay, already we have discussed. Cathode rays travel with high speed and cathode rays can cause fluorescence. We know which made to shine zinc sulfide fluorescent material. This is about properties of cathode rays. Then charge to mass ratio. What is charge to mass ratio? Here we know that charge and mass of the electron, it is highly very small. Mass of the electron, no, electron is the smallest thing in the universe. Therefore, it is not easy to determine mass and charge of the electron. Therefore, what J.J. Thomson did is he did some experiment. It is studied in your theoretical part. It is not very important in your for competitive purpose. So, I just mentioned what are the observations that Thomson did in his experiment. That is, according to Thomson, the amount of deviation of the particles from their path in presence of electric and magnetic field depends on how they deflect, how much they deflect depend on magnitude of the negative charge on particle, how much magnitude it is, negative charge it is, and mass of the particle. You know, when uh, uh, ಗಾಳಿ ಬರ್ತದಲ್ಲ ಸ್ಪೀಡ್ ಆಗಿ ಅವಾಗ ಏನಾಗ್ತದೆ, ಸ್ಮಾಲ್ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹಾರಿ ಹೋಗ್ತವೆ. ಅದೇ ತರ ಇಫ್ ಮಾಸ್ ಇಸ್ ಸ್ಮಾಲ್ ದೆನ್ ಡಿವಿಯೇಷನ್ ವಿಲ್ ಬಿ ಮೋರ್. ದೆನ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಇಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಆರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಇಸ್ ಮೋರ್ ದೆನ್ ಅಟ್ರಾಕ್ಟಿಂಗ್ ಪವರ್ ಇಸ್ ಮೋರ್. ನೀವು ಮನೆಯಿಂದ ಹೊರಟಿರ್ತೀರಿ ಮಾರ್ಕೆಟ್ಗೆ, ಮಧ್ಯದಲ್ಲಿ ಬಸ್ ಸ್ಟ್ಯಾಂಡ್ ಅಲ್ಲಿ ಫ್ರೆಂಡ್ ಕಂಡ ಅಂದ್ರೆ ಯು ವಿಲ್ ಡಿವಿಯೇಟ್ ಬೇಸ್ಡ್ ಆನ್ ಹೌ ಮಚ್ ಸ್ಟ್ರಾಂಗ್ ಯುವರ್ ಫ್ರೆಂಡ್ಶಿಪ್, ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಯುವರ್ ಫ್ರೆಂಡ್ಶಿಪ್. ನೀವ್ ಎಷ್ಟು ಡಿವಿಯೇಟ್ ಆಗ್ತೀರಾ, ಕಂಡು ಹಾಯ್ ತಿರುಗಿ ಹಾಯ್ ಹೇಳಿ ಹೋಗ್ಬೋದು, ಅಥವಾ ಹೋಗಿ ಮಾತಾಡಿಸಿ ಹೋಗ್ಬೋದು, ಇಲ್ಲ ಅವನ ಜೊತೆನೆ ಅವನ ಮನೆಗೆ ಹೋಗ್ಬೋದು. ಈ ತರ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಫ್ರೆಂಡ್ಶಿಪ್ ಮೇಲೆ ಡಿವಿಯೇಷನ್ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. ಅದೇ ತರ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಹಿಯರ್ ಬೈ ಕ್ಯಾರಿಂಗ್ ಔಟ್ ಅಕ್ಯುರೇಟ್ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಬೈ ಡಿಫ್ಲೆಕ್ಷನ್, ಎಷ್ಟು ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗ್ತಿದೆ, electric and magnetic field strength, how it is applied. Based on that, E by M value, J.J. Thomson found that 1.75820 into 10 raised to 11. It is 10 raised to 11 actually. 10 raised to 11 coulomb per kg. Coulomb per kg ಇದ್ದಿರುತ್ತದೆ. Then you know that cathode rays are negatively charged and there should be positively charged particles should be there. Negative charge ಇದೆ ಅಂದ್ರೆ positive charge ಇರಲೇಬೇಕು. So that positive charged particles are called as, or that rays are called as anode rays. Many of the properties of anode rays dead opposite to cathode rays. Cathode rays, okay, anode rays move in straight line. Cathode rays also move in straight line. Both are same. And both are made up of mechanical part and they are positively charged particle. These rays deflect towards, illnodri, cathode rays deflect towards positive plate of applied electric field. ನಾವೇನ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತೀವಲ್ಲ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಕಡೆ ಮೂವ್ ಆಗಿರ್ತದೆ. ಬಟ್ ಹಿಯರ್ ಆನೋಡ್ ರೇ ಮೂವ್ ಟುವರ್ಡ್ಸ್, ಆನೋಡ್ ರೇ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ ಕಡೆ ಮೂವ್ ಆಗಿರ್ತದೆ. And these rays travel in straight line and have mechanical energy. Yes. For different gases used in the, here this will be different and this can be asked. For anode rays, E by M value will be depend on which gas we are using and which electrode. Why? For only anodes, E by M values depend on gases we have used in ಗ್ಲಾಸ್ ಚೇಂಬರ್ ಏನ್ ಯೂಸ್ ಮಾಡಿದ್ವಲ್ಲ ಇಲ್ಲಿ ಗ್ಲಾಸ್ ಚೇಂಬರ್ ಯೂಸ್ ಮಾಡಿದ್ವಲ್ಲ, ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರೋ ಗ್ಲಾಸ್ ಚೇಂಬರ್ ಮೇಲೆ ಇಲ್ಲಿ ಏನು ಗ್ಯಾಸ್ ಇತ್ತಲ್ಲ ಇದ್ರೊಳಗೆ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರ್ತವೆ ಯಾವುದು ಕ್ಯಾಥೋಡ್ ರೇಸ್. ವೈ ದೇ ಡಿಪೆಂಡ್? ಬಿಕಾಸ್ ಹೌ ಆನೋಡ್ ರೇಸ್ ಆರ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಆನೋಡ್ ರೇಸ್ ಆರ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಡ್ಯೂ ಟು knocking out of electron from gaseous atom present in it. Therefore, electrons are kicked out from the gases. So what should remain? Gas should attain positive charge. That positive charge is called as anode rays, and anode rays travel in straight line. Okay. Therefore, E by M value for anode rays is very less. One slide has then these are also called as canal rays. Anode rays are also called as canal rays. You should remember this. And how cathode generated at cathode ray generated at cathodes, these anode rays are not generated at anode. Anode rays ಹೇಗೆ generate ಆಗ್ತವೆ? By kicking out of electron from the gaseous atom. Neutral gaseous atom ಇಂದ kick out ಆಗೋದಕ್ಕೆ anode rays are generate ಆಗ್ತವೆ. But we say that anode rays travel from anode to cathode. In general ನಾವು ಆ ಥರ ಹೇಳಿರ್ತೀವಿ. This you have to remember that approximate relative mass. Electron is, see here, electron is very, very smaller compared to proton and neutron. Compared to proton and neutron, see here, electron is 1 by 1800 times smaller compared to proton and neutron. Therefore, electron is very smaller particle in the atom. Atom alli irodralli electron is very smaller particle. Therefore, here approximate relative charge is -1 for electron, +1 for proton, and mass in kg kottidare. See here, for electron it is 9.109 into 10 raised to -31 kg, and for proton 1.673 into 10 raised to -27. See the difference. It is 9.1, but it is not bigger. Why? Because here it is 10 raised to -31 is there. Since it is 10 raised to -31 and it is 10 raised to -27, 10 raised to -27 is bigger compared to 10 raised to -31. Therefore, first, the highest mass is for neutron. It is 1.675 is there. Then for proton, then for electron. Electron is very smaller. You should remember this thing. I am going to use this mass in mass number and atomic number. So, the scientist Millikan, R.A. Millikan, he is called R.A. Millikan. He did oil drop experiment to determine charge on the electron. To determine charge on the electron, who is with the charge on the electron? He is R.A. Millikan. The experiment is oil drop experiment. This experiment is nothing but, again, gas chamber, gases will be there, and some oils will be put it in the form of droplets using atomizer. Atomizer is nothing but which converts atom to atom, molecule to atom. Yavadu molecule in the atom ge convert martidala, that we call as atomizer. So using atomizer, these oil droplets are formed and they are allowed to enter through tiny hole into the upper plate of electrical condenser. Herein use electrical field. One is positive and negative charges. Electrical field will be positive and negative charges. So these oil droplets are formed. Then the air in the chamber was subjected to the ionization by X-rays. Using X-rays, these air droplets gets ionized. You know, X-rays are very fast moving rays. And when they hit gaseous molecules, electrons will kicked out from that gaseous molecules. Therefore, gaseous molecules become positive, and that electron will be go into oil droplet, and that oil droplet will be negatively charged, and due to gravitational force they are moving downwards. But by applying some electrical field, we can make them to move towards positive charge or positive plate, so that by balancing gravitational and electric field strength, that oil what that oil droplet, we can measure its mass and charge on it. And it is very lengthy process. It is just, you should remember that using Q is equal to Ne formula. That is, Millikan observed that the smallest charge found on them was minus 1.6 into 10 raised to minus 19 coulomb. And Q on the droplet is always integral multiple of the electrical charge. Q is always integral multiple of electrical charges ಆಗಿರ್ತದೆ. Q is equal to NE. This formula you should know. How to apply this formula? ಅದನ್ನ next problem ಅಲ್ಲಿ ನಾವು ನೋಡುವ ಈಗ. See here. Find the E by M value of alpha particle. Alpha particle ಅಂದ್ರೆ already ಹೇಳಿದೀನಿ, it is helium plus 2. With respect to hydrogen atom ಅಂತ ಕೇಳಿದ್ದಾರೆ. E by M value. E is nothing but charge. What is charge on helium? It is plus 2. And what is mass of the helium? We know the mass of helium is 4. Therefore, 2 by 4 will be our 0.5. That is answer. 0.5 will be our answer. The next question is, in an oil drop experiment that we have discussed here, the charges on oil drops were found as 1.5 into 10 raised to minus 5, 3 into 10 raised to minus, 10 raised to minus 15, 3 into 10 raised to minus 15, 4.5 into 10 raised to minus 15, 6 into 10 raised to minus 15. Calculate the magnitude of the charge on electron. We have to calculate the magnitude of the charge on electron. How to find out? Here, we should consider which is the smallest integer by which we can multiply these numbers. Here, we can multiply 3 with 1.5. 1.5 into 2 will be 3. And 4.5, again 3 into 1.5 will be our 4.5. And 6 into 1.5, 4 into 1.5 ಮಾಡಿದಾಗ 6 into 10 raised to minus 15 ಬರ್ತದೆ. Therefore, charge on the electron in same all cases, and it will be 1.5 into 10 raised to minus 15. I can multiply each 1, 2, 3, 4 integral multiple ಏನಿದೆ that I can multiply with charge on the electron. This is smallest quantity. ಈ ಕೊಟ್ಟಿರೋದ್ರಲ್ಲಿ ಈ ತರ ಕ್ವಶನ್ ಕೇಳಿದಾಗ ಯಾವ ತರ ಸಾಲ್ವ್ ಮಾಡೋದು? ಯಾವುದು ಸ್ಮಾಲೆಸ್ಟ್ ಇಂಟಿಗ್ರಲ್ ಡಿಜಿಟ್ ಇರ್ತದಲ್ಲ, ಅದರಿಂದ ಉಳಿದಿದ್ದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಲಿಕ್ಕೆ ನೋಡಬೇಕು. ಯಾವುದು ಸ್ಮಾಲೆಸ್ಟ್ ಇರ್ತದೆ ಅದನ್ನ ಚಾರ್ಜ್ ಆನ್ ದ ಇಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. Then comes our models of atom. First one is Thomson model. It is very easiest one. Okay. Thomson's model of atom. Here, Thomson initially he considered that atom which is circular in shape, positive charges are uniformly distributed throughout the atom. He considered that in atom, positive charge is uniformly distributed and electrons are embedded in it. Just like he also called it as watermelon model. Why? Because atom is ವಾಟರ್ಮೆಲನ್ ಅಂತ ಅಲ್ಲ ಮೀನಿಂಗ್. ವಾಟರ್ಮೆಲನ್ ಅಂದ್ರೆ ಆಟಮ್ ಅಂತ ಮೀನಿಂಗ್ ಅಲ್ಲ, ಗೊತ್ತಾಯ್ತು. ಅವನು ಐಫೆಲ್ ಟವರ್ ಅಷ್ಟೇ ಎತ್ತರ ಇದ್ದಾನೆ, ಕುತುಬ್ ಮಿನಾರ್ ಬುರ್ಜ್ ಖಲೀಫಾದಷ್ಟೇ ಎತ್ತರ ಇದ್ದಾನೆ ಅಂತ ಹೇಳ್ತೀವಿ. ವಿಚ್ ಮೀನ್ಸ್ ಹೀಸ್ ಬುರ್ಜ್ ಖಲೀಫಾ ಅನ್ನೋದು ಮೀನಿಂಗ್ ಅಲ್ಲ. ಹಿಸ್ ಹೈಟ್ ಇಸ್ ವೆರಿ ಟಾಲ್. ಅಂತ ಮೀನಿಂಗ್ ಬರ್ತದೆ. ಅದೇ ತರ when he consider atomic structure to watermelon, which means if you consider watermelon which is spherical in shape, and we know that red color pulp is uniformly distributed wherever you get same portion, so it is uniformly distributed, just like positive charges are uniformly distributed throughout the atom. And just like seeds in it, how seeds are embedded in it, just like that electrons are embedded inside the atom. And atom as a whole is neutral. Atom as a whole, it will be neutral. That embedded electrons neutralizes whatever the positive charge is present. This is said by Thomson, and it is also called as plum pudding model. Then what are the limitations of Thomson's atomic model? It can explain neutrality of atom, but it couldn't explain the results of alpha ray scattering experiment carried by Rutherford. Then what is alpha ray scattering experiment by Rutherford? ಹಾಗಿದ್ರೆ ಒಂದು ಲಿಮಿಟೇಷನ್ ಆಗಿದೆ ಅಂದ್ರೆ ಅಥವಾ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್ ಆಗಿದೆ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ರುದರ್ಫೋರ್ಡ್ ಮಾಡೆಲ್ ಅಥವಾ ಆಲ್ಫಾ ರೇ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಫ್ ರುದರ್ಫೋರ್ಡ್? Here, Rutherford alpha ray scattering experiment. He considered one radioactive material. You know, radioactive material radiates radioactive particles or radiation. They emit radiation, and he slit alla use ಮಾಡ್ತಾನೆ. Let it be here, slit is used. And when this rays passed through this gold foil, when this rays passed through this gold foil, and again ಇಲ್ಲಿ zinc sulfide ಅನ್ನು ಯೂಸ್ ಮಾಡಿದ್ರು. This is zinc sulfide coating, and this is gold foil. This is gold foil. So according to Thomson's model, whatever the radiations or alpha particles are passing, whatever the alpha rays are moving, they should bounce back. Bounce back. Why? Because atom as a whole is neutral, and which is positive charge is uniformly distributed. We know that alpha particles are positively charges. ಹೇಳಿದೀನಿ, 2 charges ಇರ್ತಾವೆ, 2 positive charges. So when positive charge hit positive charge, they should bounce back. But this wouldn't happen. So ಹಾಗಿದ್ರೆ ಏನಾಯಿತು? So when alpha ray hits this gold foil, most of the alpha rays were passing through this gold foil, and only some of them were deflecting with some angle. And only 1 out of 20,000 rays were bouncing back with 180 degree. 180 degree ಅಲ್ಲಿ ಬೌನ್ಸ್ ಬ್ಯಾಕ್ ಆಗ್ತಿರೋದೆಷ್ಟು? ಓನ್ಲಿ 1 out of 20,000 rays. Other rays, 99% rays were passing through this gold foil. Therefore, the thin gold foil had circular fluorescent zinc sulfide screen around it. This is zinc sulfide screen. Whenever a particle struck the screen, a tiny flash of light was produced at the point. E point ali tiny flash produce ಆಗ್ತದೆ, so that they determine how the particles are traveling, whether they are deviating or in straight line or bouncing back. So whenever this is about alpha ray scattering experiment. Therefore, what are the observations? Observations ಅಂದ್ರೆ ಏನು ಬರ್ತದೆ ಈಗ ಹಾಗಿದ್ರೆ? Most of the alpha particles passes through it without any deviation or deflection. That is 99% of alpha particles. Some of the alpha particles were deflected through small angle. With only small angle they deflected, and very few particles, 1 out of 20,000 rays were deflected by large angles, that is 180 degree. These are the observations. What are the conclusions? Hagidre, Thomson's model have limitations. Then atom is spherical in shape, having size of order 10 raised to minus 10 meters. It is 10 raised to minus, actually it is 10 raised to minus 10 meters, 10 raised to minus 10, 10 raised to minus 10 meters. And most of the space in the atom is empty. Most of the space in the atom is empty. You know that 99% of the particles were passing through the atom, therefore empty, we can say. Then the positive charge has to be concentrated in very small volume. Positive charge is concentrated in very small volume because only 1 out of 20,000 rays were bouncing back. The electrons equal in number of net nuclear positive charge revolve around the nucleus. Electrons, whatever are there, they are revolve around the nucleus. Nucleus are nothing but which is concentrated at the center. Concentrated at the center. The centrifugal force arising due to the revolution of electron balances the force of attraction of nucleus and the electron. See, what is centripetal force? It is towards the center. Center is nothing but nucleus. Therefore, the centripetal force, that is attraction towards nucleus, balances by, counterbalances by force of attraction of the nucleus and the electron. Whatever the electron is revolving, that counteracts the centripetal force. So, again, there is limitations of Rutherford model. What are the limitations of Rutherford model? This model could not explain the stability of atom. It couldn't explain how much it is stable, why the atom is stable, because according to Maxwell's classic theory, an accelerated charged particles while moving it liberates energy. ಯಾವುದೇ accelerated particle ಇರ್ತಾವಲ್ಲ, which liberates energy when it is moving. So it should emit energy. That charged particle which is moving should emit energy, and at some time it has to fall. That electron has to obey spiral path and fall to nucleus, which means there will be no atoms, no existence of atoms. Therefore it couldn't explain the stability, but we know atoms are exist and we are exist, we are made up of atoms. It says nothing about electronic structure of atom, that is how electrons are distributed around the nucleus. In an electron is revolving, but where electrons are revolving, he couldn't explain. Distribution of electrons, he couldn't explain. These are the some drawbacks or limitations of Rutherford model. To overcome this Rutherford model, next model proposed by Bohr. Bohr proposed the model. Before studying that, we should aware of some atomic terms. They are very important here. What are the atomic terms? Atomic number. Atomic number of an element is number of protons contained in the nucleus. If it is neutral atom, then number of protons will be equal to number of electrons. Number of protons equal to number of electrons. If it is only neutral atom, then protons will be equal to neutral. And what are nucleons? Nucleons are protons and neutrons. Here, see here, nucleons related to some nucleus. So The particles which present in a nucleus, we can call it as nucleons. The protons and neutrons, we know that they are present in the nucleus, therefore we can call it as nucleons. So these are the fundamental particles and collectively called nucleons. What is mass number? Illi use ಬರ್ತದೆ ಅಂತ ಹೇಳಿದೆ ಯಾವುದು? Remember that masses of electrons, protons and neutrons. Mass of the electron is very negligible compared to masses of protons and neutrons, you know. Therefore mass of the electron can be neglected while determining the mass of the atom. Therefore we only consider mass number. Mass number ಅನ್ನು ಯಾವುದು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? Mass number equal to number of protons plus number of neutrons. Number of protons ಮತ್ತೆ neutrons ಅನ್ನ ಸೇರಿ ನಾವು mass number. It is mass number. How to represent an element? X is any elemental symbol. We know that hydrogen to at least up to zinc, you should remember its atomic number and its mass number and its a representation. X is, if I consider for hydrogen, it is H. H is nothing but X. Z is atomic number. We know that for hydrogen 1 is its atomic number and mass number is 1 for hydrogen. And here how many protons? Since atomic number is 1, mass number is 1, only one proton is there. Hydrogen contains no neutrons. But isotopes of hydrogens are there, they contains neutrons. If it is sodium, sodium 11, 23, if I consider it as 23, 11 is its atomic number, which means number of protons or number of electrons equal to number of protons or electrons equal to 11 and number of neutron is equal to 23 minus 11, which is 12 neutrons are there. This is how finding out number of neutrons and number of protons. Protons and electrons in neutral atom will be equal to Z value, that is atomic number. But when you subtract mass number and atomic number, you will get number of neutrons. This is very, very important. You should remember how to do such things. And some terms, isotopes, the atoms of the same element with different mass number are called as isotopes, which means atoms with some number but different mass number are called as isotopes. So for hydrogen 3 isotopes are there: protium, deuterium and tritium. Protium is 1H1, deuterium is 1H2 and tritium is 1H3. These are the examples of isotopes. ಇದನ್ನು ನೆನಪಿಟ್ಕೋಬೇಕು. These atomic terms are very, very important concept. ಕೇಳಿರ್ತಾರೆ usually ಇದನ್ನೆಲ್ಲ. Isobars, atoms having same mass number but different atomic number are called as isobars. That opposite to isotopes. Isobars are having same mass number but different atomic number. Atomic number ಬೇರೆ ಬೇರೆ ಇರ್ತದೆ, ಆದ್ರೆ mass number ಸೇಮ್ ಇರ್ತದೆ. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡೋಣ ಅಂದ್ರೆ ಐಸೋಟೋಪ್ಸ್ಗೆ, isotopes are like if you consider wheel packet 5 rupees, 10 rupees, 15 rupees, they are all of same company but prices or quantities are different. Just like isotopes, company same ಇದೆ, hydrogen company ಇದೆ, company ಅನ್ಬೇಡ್ರಿ, each element ನಾನು ಹೇಳ್ತೀನಿ. ಅಂದ್ರೆ hydrogen is, if you consider hydrogen as company, all are having same company brand but different quantities or different rates. But isobars, they are just like same 10 rupees wheel, 10 rupees exo, whatever the detergents are there. ಅದೇ ತರ company brands are different but quantity or the price is same. All are 10 rupees, 20 rupees, like that. So these are about isobars. This is about isobars and isotopes. The next one is isotone. What is isotone then? Isotones are atoms are having the same number of neutrons but different number of protons are called as isotones. ನಮಗೆ same number of neutrons ಇರಬೇಕು. Neutrons should be same but different number of protons. Protons may be different. They are called as isotones. See here, when I consider carbon 14 and nitrogen 15. In this case, number of protons 6. Number of proton is 6 and here it is 8 and it is 6. But what we require number of neutrons. Neutrons should be same. Number of neutrons should be same. Then isoelectronic species. The name itself suggesting isoelectronic is nothing but atoms or ions having same number of electrons. This is very easy. They are isoelectronic species. When you consider potassium plus S2 minus, see here, potassium having atomic number 19. Potassium atomic number is 19 is there, but atomic number 19 means number of electrons should also be 19. But it is K plus 1. Plus 1 is there means we have to subtract 1 from 19. Then when it is ion which is having plus charge, we have to subtract that much charge from its atomic number, which is very important. If it is minus, we have to add that much electrons or that much charges to the atomic number. See here, S2 minus is that 16 atomic number. We know that atomic number equal to its number of electrons in neutral case, but it is not neutral. It is 2 minus, which is anion. Anion is I have 2 minus means there are 2 extra electrons are there. There are 2 electrons extra. Therefore, I have to add 16 plus 2, which is 18. Similarly, Cl minus mercury, Ca2 plus mercury, calcium. Their protons are given, atomic number means proton. Electrons are also same. For Cl, I have to add 1 electron. For Ca2 plus, I have to remove 2 electrons. Therefore, it is 20 minus 2. 18 electrons are there. But in these cases, all the electrons are same. All are 18. These are called as isoelectronic species. The next one is isosters. The molecules, it is just similar to isoelectronic species. Isosters are similar to isoelectronic species. They are molecules having same number of atoms with same number of electrons. Here, for this one, for isoelectronic species, we no need number of atoms should be same, but for this one, isosters, we need number of atoms in a molecule should be same and also their electron should be same. That is isosters. So see here, isosters for NO2. When you consider NO2, 3 atoms are there. And here for nitrogen, how many electrons are there for nitrogen? 7. Plus for oxygen it is 8. Plus 8 because 2 oxygens are there and I am adding plus 1. Why plus 1 is added? Because you see here minus charge is there. Minus charge irodake nanu plus 1 add ಮಾಡ್ತಿದ್ದೀನಿ. It is 24 electrons. See, oxygen ಎಷ್ಟಾಗ್ತದೆ ಅಂತ ನೋಡುವ. 3 oxygens are there. 8 plus 8 plus 8. Again 24 electrons are there. For oxygen, number of electrons are same for NO2 minus and O3. And in O3, how many atoms are there? 3 atoms are there. Therefore, 3 atoms and 3 atoms, 24 electrons and 24 electrons. Therefore, isosters, these two are called as isosters. You just practice more number of such examples: isostars, both isoelectrons, electronics, isotopes. You have to go with more examples. And isodiapers, atoms having the same difference between number of neutrons and number of protons. It is quite complicated but simple also. Number of difference between number of neutrons and number of protons should be same. ಅವಾಗ ನಾವನ್ನ isodiapers say here. For example, uranium 238 and thorium 234. In this case, number of neutrons find out ಮಾಡೋದು ಹೆಂಗೆ? 238 minus 92. You will get number of neutrons because mass number minus atomic number, it is 146. 146 minus 92. 92 is number of proton. Neutron minus proton. 146 minus 92 will be 54. And similarly, for thorium, it is 54 electrons. Then electromagnetic wave theory. See, ಹೇಳಿದೀನಿ Bohr's theory ಹೋಗೋದಕ್ಕಿಂತ ಮೊದಲು we have to study some certain things. Already you may be idea regarding electromagnetic waves. I think you have studied in your theory classes that electromagnetic waves are nothing but the waves which contains both electric and magnetic field. Both electric and magnetic field are perpendicular to each other. If this is wave, if the wave is moving, then electric and magnetic field are perpendicular to each other. They are perpendicular to each other like this. They are called as electromagnetic waves. So electromagnetic waves are the waves which consist of electric and magnetic field with them. They are called as electromagnetic waves. The very good example for electromagnetic wave is our sunlight. Sunlight is a good example. Then we have to study what are the properties of electromagnetic rays. So electromagnetic waves. Here, you know that waves, when you see ocean, it consists of waves, and waves are always continuous. Therefore, ಇಲ್ಲಿ ಒಂದು sentence mention ಇದೆ, the energy emitted from the any source continuously in the form of radiation and is called as radiant energy. Here, continuous is very important. This continuous energy is continuous in wave nature. The radiation consists of electric and magnetic field, we know that, and all the radiations are having speed 3 into 10 raised to 8. It is 10 raised to 8 meter per second. That is, per second it will travel 10 raised to 8 meters. All the electromagnetic rays will be having 3 into 10 raised to 8 meters per second. And these waves do not require any material medium to propagation. We know that between sun and earth there is nothing. It is space. So although there is space, that rays travel to us and they reach us, which means that electromagnetic radiation do not require any medium to travel. This is a good example. Some characteristics of wave we have to study, that is wavelength. Wavelength is nothing but the distance between consecutive crest and trough. It is called as wavelength. See here, these are called as crest, upper part, and down part is called as trough. So distance between this consecutive crest or consecutive trough are called as wavelength. It is the length, distance. Its SI unit is meter, but picometer, nanometer, angstrom, centimeter are also used. You should aware, you have studied in some basic concept of chemistry, what is pico, what is angstrom. You have to recollect that memory. And what is frequency? What is frequency of radiation? Consider all of you are in one room and I have opened the door. Now, in 1 second, how many of you are passing through the door? Are nothing but frequency. Similarly, when I consider this as the point, if I consider this as point, and within 1 second, if I consider within 1 second, this much waves are passing through this point, then this is called frequency. If three waves are passing, then we call it as 3 hertz or 3 cycle per second, CPS. If two waves are passing through single point in 1 second, within 1 second is important, 2 hertz. Therefore, hertz is its SI unit. SI unit is hertz for this frequency. It is denoted by, frequency is denoted by nu. Frequency denoted by nu. ಈ ತರ ಬರಿತೀವಿ. V ಅಲ್ಲ, nu ಅಂತ ಬರಿಬೇಕು. It is frequency. Then time period. It is time taken to complete for one complete oscillation. It's just like ನೀವು ರನ್ನಿಂಗ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತ ಇಟ್ಕೊಳ್ರಿ, 3000 ಮೀಟರ್. ಟೈಮ್ ಪೀರಿಯಡ್ ಯು ರಿಕ್ವೈರ್ ಟು ಕಂಪ್ಲೀಟ್ one cycle will be different for different people. Similarly, time period is different for different electromagnetic radiations, and it can be denoted by capital T. Time period is denoted by capital T, and equation is C is equal to lambda by time period. Lambda is wavelength. Wavelength is lambda, denoted by lambda, and C is always velocity of light. C is always velocity of light, and T is time period. This is the relation you should remember. And wave number, number of wavelength per unit length. Wavelength or number of waves. How many number of waves present in unit length? That is called as wave number. ಎಷ್ಟು, if I consider this unit length, ಅಥವಾ previous one ಹೋಗೋಣ. Here, if I consider this unit length, this as unit length, ಈ unit length ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, if it is 1 centimeter ಅಂತ ಇಟ್ಕೊಳ್ರಿ, ಇಲ್ಲ ಇಟ್ಕೊಳ್ರಿ ಅಂತ, ಅವಾಗ how many waves? Only half wave is present. Here 1 2 3, nearly 3 waves are there. Therefore, frequency of this is more compared to this one. Idu compare madidre this frequency is more. And amplitude. What is amplitude? It is, again previous one you know, it is height of the crest or depth of the trough. If I consider this as the base, and it is maximum height or minimum depth. ಈ depth ಅನ್ನು ನಾವೇನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, it is called as amplitude. ಇದನ್ನ ನಾವು amplitude ಅಂತ ಕರಿತೀವಿ. This is called as amplitude of the wave. Velocity is defined as the distance covered by wave in 1 second. In 1 second, how much distance covered by the wave? That is called as velocity. Therefore, velocity is equal to the relation between velocity and frequency. This is frequency. Nu is equal to C by lambda, or C is equal to nu lambda. We can say nu is equal to C lambda, or C is equal to nu by lambda. This is about velocity, and different electromagnetic radiations are there. I think already time is up, and I have to end this session, I think so. So let us meet in the next class. And before concluding, I think the concept I have learned today or taught today. So any doubts, if you have, if you ask, then I try to clarify it. Yes. Mm, okay. Thank you and happy evening. We will meet in the next session, that is tomorrow. I hope you enjoyed the class and you learned something. Okay. Bye.